This is AI pipelines with OPA.
OPEA.
OPEA.
OPEA, yeah, OPEA.
This is a long-standing argument with those of us even internal to the group. The official pronunciation is OPA, but say what is ever comfortable for you.
Open Platform for Enterprise AI. It's a bit longer, but it's
yeah.
No.
Yeah. So yeah, we'll do a little bit of talking about why this project exists, introduce you to the project, and let you know how to get involved. So first of all,
yeah, go ahead.
Who knows what RAG is? Okay, most of you.
Okay, cool.
You want to go ahead and give a good, this is a very good meme for RAG.
Yeah, so when we talk about RAG, we mainly use RAG because when we try to rely on the LLMs, we know that the LLMs, they don't know or they don't know the context. So you need to provide the context somehow externally. So this is what we'll be doing mainly today. We will be diving a bit on RAG, how OPEA works. But actually, that's a good, funny thing, right? So we think that the LLMs can solve everything for us, but actually they don't. So we need to use some other approach like RAG to give the context to the LLMs.
Cool. So let's set this up.
Yeah.
And just a little bit about our backgrounds. I'm Melissa McKay. I'm a software engineer primarily. For the last few years, I've been a developer advocate. And I am more concerned in the DevOps side of things, the development side of things, and the deployment side of things. And when it comes to RAG applications and AI, a lot of that has been very brand new to me, and I've learned a ton from Easy.
Yes, I'm Ezequiel Lanza. I work for Intel as an open source AI evangelist. I'm also part of the Linux Foundation AI and Data. I'm the tech chair and the board member. I'm mainly working on evangelism, DevRel, and trying to make fun use cases, content blogs, and everything. Mainly with AI, now agents, RAGs, LLMs, and open source, of course.
I joined OPEA last year. I'm wearing the shirt from the very first community day that the project had.
I don't have mine. So.
And last year I was part of the technical steering committee for the project. We just went through a transition, so we have some new members along with some of the remaining members for the TSC. So it's going to be an exciting year this coming year.
Yeah.
So what Easy and I did together was try to figure out how can we create a talk that's going to be for a wide audience. This isn't necessarily an AI conference, so we may have some folks that aren't really familiar with this stuff. So some of this stuff we're doing for the first time. You'll have to let us know what you think. But basically, we're going to create a RAG application. We're going to show you a live demo of this project in action, and we're going to talk about what exactly it's doing. So we're using this example. How many of you are familiar with Dragon? If someone walked up to you on the street and said, "What is Dragon?" what would you say? Speech to text, okay. Anyone else?
Exactly.
Mythical creatures. Yeah, that's what I would say. That's why I chose this little, So Dragon, this is a very not common name of something. In fact, Easy, where did you find this?
Yes, I actually find it because we used to work with Kubernetes a lot, so we are reading for papers and seeing what are the new techniques. And we find this kind of a scheduler for Kubernetes, and the name is Dynamic Resource Scheduler for Deep Learning Training in Kubernetes. And I don't know why they call it Dragon, but they call it Dragon.
Very cool. So if someone, if you go out to Google and Google Dragon, or you ask someone on the street, if someone asked me, I would have no idea. I certainly wouldn't give you an answer like this, deep learning with autoscale and gang schedule on Kubernetes, right? It's information that isn't so popular. So this is where RAG comes in, where we want to make our application respond by providing it some context. And there was this paper that was published in, I'm going to read this because this is a long name, the 2027 International Conference on Advanced Informatics, Concepts, Theory, and Applications. So this paper came out talking about Dragon. And what I would like to do is to be able to set up an application where I can ask my LLM, what is Dragon? And it will know what I'm talking about and give me the appropriate responses.
Yes. And when we start working, if we are working in AI or in data science or machine learning, we go to Jupyter Notebooks.
Yeah.
Right? How many of you are using Jupyter notebooks?
Awesome.
Good.
Awesome.
So
You put me to shame because I was new to Jupyter Notebooks. I'm a developer. I use an IDE. I'm like, what is this thing? Why are we doing this? And what do you expect me to do with a Jupyter Notebook, right? But it's an excellent tool for being able to create a POC, go through and actually document what you're doing, make what decisions you're making, and actually run Python to make sure that you're going the right direction.
yeah, so the first thing that I would do for you is let's create a RAG Jupyter notebook, right? So as all of you, I will not run everything because we don't have 30 minutes or 40 minutes. So I will be setting up in a Jupyter notebook how to create a RAG application, which is basically running locally in my machine, just because I don't want to pay OpenAI the tokens. I don't have a huge server, so I can run it here in my computer. I will be using a model that is part of the Llama CPP. If you are familiar, are those optimized models that you can run locally in your computer. So in that case, I will be downloading this model from Hugging Face. So the code that I have here, this is public available, so we'll be sharing in case if you'd like to play it. So when we are talking about RAG, we need the LLM. So we know that the LLM will be this optimized LLM. And we need a way to put, or a place to put your PDF documents. So we need a vector database, and we need an embedding microservice, and that we'll be talking later. Not microservice, the embedding function so far. So basically, I will be using LangChain for this. For those of you that are working with RAG, are you using LangChain? Are you using Llama Index? Are you using C++? LangChain, mainly LangChain, all right. So I will be using all the functions as a normal developer would do. So I will be creating this. I will be downloading the model from Hugging Face. The model weighs 4 gigabytes or 5 gigabytes. So these are all the models. I will be ingesting the document, which is basically, I need to use a function, which is very simple, just extract the model, extract the PDF, and from the PDF, I will convert the PDF to text. And that text, once I have it in text, right, the consumable text, I would like to do the chunking, which is pick up the part of the text, and those part of the text, I will say this is one chunk, which has one concept. There are some things that you can play here, 1,500, the amount of the chunk size. I said just 1,000. With the overlap, which is something important, how are those chunks overlaps? I create those chunks because of that PDF. I had 29 chunks. The next part of the text is to convert it to embeddings. So text you cannot make comparison if you compare text with text. So you need to have numbers or some way to do comparisons or similarities. So I'll be using the embeddings model from Hugging Face, which is actually a model that you give text and you get vectors that represents the text. And I'm storing those vectors in the vector database. In that case, I'm using Chroma because this is like the first testing part. When you start playing, you start working with Jupyter notebooks. And I will be creating a prompt to the LLM saying, I'll be creating actually two, one that works directly with the LLM, and the other one would work with the RAG pipeline. So I will say for the direct LLM, you are a helpful assistant, answer the following question based on your knowledge. And the prompt for the RAG will say you are a helpful assistant, answer the question based only on the provided context, right? And what will be happening? I'm loading this model in memory. I'm setting some parameters like temperature, amount of tokens, and everything. This is not a very specific AI talk, so we will not be going in details. And we finish creating the pipeline, right, with LangChain, which you mainly say, what is the LLM that I will be using? What is the vector database that you're using? What is the retriever that you are using to do the comparison between the question and all the vectors? We will go a bit deeper on that later. And I create that, and I'm able now to run this, which is actually prompting both. It's prompting just the LLM. I'm making the same question, what is Dragon? And I'm making the question about what is Dragon using the RAG context. So I didn't run this, so let me run all. Like you will see that it's pretty fast using llama CPP. So in that case, let's wait 1 second. All right, I will now start debugging now. But the same we'll do with the script later. But this got an error because I didn't create the Chroma database locally. So I will now be creating that manually. But actually, when we tried both, we'll see that the first question that the LLM gives you is a methodological creator. And when you will make the question with RAG, it will say that it's a dynamic scheduler, right? We're not seeing here, you should trust me, but when we go on the script, we should be able to see what the RAG application was. So I have this notebook.
So the notebook's great, all right, but when it comes to me, you can't just throw a notebook over the wall to me and go deploy a notebook and say, everyone use this is our new service. So what we need to do is make this deployable, and that's one of the goals of OPEA. And that's the step-by-step that we're going to take. First, we have a proof of concept. We have a problem we're trying to solve. We have the proof of concept proven out in a notebook. Now we want to make something deployable. So step one, simplest thing that works. That's one of the things I learned early on. Just do the simplest thing. And the simplest thing is to just take this script, wrap it up, deploy it on a server. You're done.
OK, yes, yeah. So by with Jupyter Notebook is great because I just write some of those columns, I execute it, and it's great. But I do have a script that I created awesome. That is actually more the programmatic part. Right? So we're using concepts like classes, objects, functions, which is something that I started as a data science probably 10 years ago. And that part was very challenging for us when we are training models, when we are doing this. Because we don't used to. We just finished with the model. We give this model to someone, which is DevOps, or who knows.
Exactly.
And they do it.
And that's my world. My world is very much programmatic. I'm used to organizing code, used to seeing it in a certain format, a certain way, organized a certain way. So it's interesting world that we live in now where we have both of these sides trying to come together and put something out there that is quality and scalable. And that's one of the benefits of the project.
So this script basically does and thus creates the RAG pipeline, the same RAG pipeline as we had before, but with a different mindset. Right? So I have functions, I have a class. There's like 101 Python, right? So I have the classes, which is the RAG demo system, and I put all the functions just to separate that. For instance, how I do the cleaning, I would like to have a function that specifically does the cleaning. Right? For instance, how you check if the documents are duplicated, or what is the overlap, or how you configure that. I would like to have a specific function to do that. So if I like to do any updates, I would like just to change on that function. Right? So this is what this script does. It loads the LLM in memory. It cleans up the documents. It builds the RAG pipeline. It queries the RAG. There are some functions specifically to interactive mode, because I imagine that you would like to run the script, and you would like to start interacting with the LLM or with the application. So in that case, I created a script, and if it works, basically it's a Python script which is interactive. I will be giving the PDF to this RAG application. The PDF is the same that we showed before, and I will be running this script. And the script will be doing something similar as we did before. Right? We'll be ingesting the documents, we'll be loading in memory the Llama CPP version model, we'll be downloading the embeddings model locally, and we'll be giving you a prompt to give you that answer. And now it says, enter your question, and I will make the question, what is Dragon? Right? And now what is happening is, my question is going to the retriever, and the retriever is doing this comparison, is getting the most similar documents, and those most similar documents is going to a new prompt, and that prompt goes to the LM. And the answer is, Dragon is a resource scheduler. Dragon is a resource scheduler that schedules distributed jobs using open scheduling and auto-scaling. So I got an answer. And I can also keep interacting with this see if I would like to make any questions about this specifically PDF. So I will give you the script.
Okay,
So you can
it's
use
great. The script is great. I can deploy this and run this, but you can see where we're going with this. What are some of the problems with just having a script sequentially running these things?
What is the problem?
Yeah. What would we want to do differently?
Which problem you can guess? Different kind of environments, different dependencies, different kind of hardwares.
Yeah. Maybe scalability.
Scalability.
You may one part of this program may need a lot more memory than another part. How about maintenance? Maintenance is a nightmare because if you change one part of it, you may be adding a dependency or updating a dependency. Now you have to consider all the rest of the application that may be using that same dependency and maybe possibly breaking the rest of the application. So what we're going to do is break this down. This is a monolith. We're going to try to pull out pieces and make this into different microservices instead.
And you have this monster. I mean, we didn't talk about the monster.
Yes.
So it's a fun monster. So we don't want to have this kind of deployments. I mean, probably it works, but it's not scalable. It's very complicated to maintain, to add new features, and so on. So you said to try to isolate those functions. So
let's go back to the drawing board. I'm going to go back to the team, and we're going to try something new today. This was a conversation that Easy and I had earlier, and I'm like, hey, Easy, walk me through this exactly. What are the concepts that we need to build out into individual microservices? And what I know right away, just from my own experience, is we need the vector database. That needs to be its own thing. Even with the script, right? You need to be able to include a vector database. So I'm just going to put the vector database here. Okay. And the next part of this is we have our context. I'm going to reference that. So we have our little PDF here that has information about Dragon on it. Now, for the vector database, we need to get this data in there in order to even communicate with it. So we need to convert it to numbers. So first, we need the text, the PDF, and we need to have the embeddings, which will take the text and we'll convert it to numbers. So we're going to vectors. Basically ingest this PDF. It's going to translate it into something understandable that can be stored in the vector database in an efficient way. Okay, so what's next now? Well, we now have the data in our vector database, so now we can start making questions to our application. Because we already have the context stored, so now we need to start making questions. So this might be a service, we can call it a retriever. Yes. So a specific microservice that is doing this. So this retriever, when we make the prompt about Dragon, it will also convert this to numbers, correct? And then send that information back to us, and we need to put that in the vector database, right? Yeah, we need to get the most similar documents. Because here in the vector database, we have 50, 40 chunks, and we would like just to get the most similars, the 2 or 3 more similars. Okay, so at this point, what we're getting back from the vector database is our chunks. And we're going to get like the top 3 options here. Yeah, but wait. There's something here that it's cool, but you cannot put the 3 in the prompt. You need to put the more similar document. So for that, we should add another microservice that now we need to do a second process. We need to do a double checking, or kind of that double checking, to see, okay, how similar are those documents with my initial question? Okay, so what should we call this service? Re-ranker. Re-ranker, okay. So I'm just going to label a service here. I'm going to call it RR, re-ranker. Yeah. And what this will do for us is, collect these 3, determine the top chunk. That makes sense. Yeah. And now what? And that now is our prompt.
we put this information, which will contain this chunk, which will contain information about our question, and we have a new prompt. The same thing as we showed before, a new prompt. You are a specific LLM. You answer the question based on this context. So it's mainly
So we have
prompt
our
engineering.
prompt
Yeah.
plus our context, and this is when we're actually contacting the LLM and
LLM.
getting our.
Yeah. And we get the answer.
we
This
get the
great
answer we
answer
expect.
that we got in the script, not in the Jupyter Notebook. The one that we got in the script. And this is mainly the process.
Okay.
Right? So
we're looking at several microservices here. We've this one for sure, the system here that will do the conversions. We have the vector database. We have the retriever. We've got, what is this called again?
Re-ranker.
The re-ranker, and we have the
LLM.
LLM. So you can see there's lots of different components here, and it would really be nice, this is kind of back to our little monster diagram with all those Legos put together. It'd be nice if there's a standard for this, so that we don't have to figure this out all over again and redraw this map all over again every time. That is where OPEA comes in.
And we don't want to be locked, right? Because once we do this separation, for instance, I would like to run the LLM whatever I want in a specific hardware. I would like to scale it. I would like to use multiple things. So I don't want to be locked to a specific hardware or to a specific application or script that I'm using. I would like to consume that as an API, everything as an API, right? The embeddings as an API, the vector database as an API, everything as an API. So even though this solution can be very simple, because if you see the Jupyter Notebook, it was very simple, like was more than 20 lines, let's say 50 lines of code. But how can we scale and how we do that? So having similar or very little microservices doing one specific thing, that is the best way to solve those kind of issues. So let me switch. I love this. I'm trying to change it. Okay. So this is basically what OPEA provides, which is this platform. OPEA, how many of you heard about OPEA?
Cool.
Oh, cool. Okay. So OPEA, for those of you that don't know, is an open source platform that organizes the GenAI calls, but it's basically, I said open source platform because it's not an open source project when you do pip install and it works. It's a platform. So you need to have access to Docker Compose or Kubernetes or a platform environment. So it is composable building blocks, which are those building blocks that Melissa said before. So we'll give you those building blocks so you can build your own application. It integrates LLMs, data stores, prompts engines, and RAGs. We show the example with RAG just to visualize what OPEA is, but actually OPEA has more than 25 blueprints, has agents blueprints, graph RAGs, doc summarization, code generation, they have multiple examples. Code translation, multimodal. I mean, I didn't play with multimodal, but there are multimodal too. And there is a tool that is related with the evals part. So if you are doing evaluations on, I would like to know how the model performed, what is the latency of the particular microservice, or what is the throughput, and so on. There is a tool that is part of the project that gives you this evaluation part.
Awesome. So yeah, just to be clear, this isn't just for RAG. There's lots of other applications here. There are a lot of companies that were excited about this. If you go and check out the project, you'll see there is a lot of Intel contributions. They were very strong behind this. But I mean, we also have AMD. We also have a variety of other folks in the arena getting involved in this. 55 at the last count. So pretty cool, pretty exciting. This is the OPEA vision, to enable enterprises to develop and deploy GenAI solutions powered by an open ecosystem that delivers on security, safety, scalability, cost efficiency, and agility. So now this, to me, means this isn't just the simplest thing that works. This is something that enterprises would be able to use, be able to plug into, and be able to fall back on those values of open source, where if it's open source and everyone's involved, this is going to be quality. This is going to be good and will address a lot of the different use case scenarios that people have. So why get involved?
Yeah.
Well, we need some accountability. There's lots of different organizations here that focus on different things. I know, like when I was with JFrog and JFrog got involved with this project, we were very interested in the MLOps portion of it. Like, how is it actually going to be deployed? What's the format? Things like that. And then also security. You know, how do we maintain best practices and make sure that our software is coming from trusted places, and that we can guard our assets here. Also, just so that not everyone has to start out with trial and error, it's kind of nice to have something to start with, and we've got it today. So plugging into OPEA, these were some of the enterprise concerns that I came in wanting to know immediately. I wanted to know about how they were managing these different containers. Where were they going to be stored and how they were going to be managed? Where were models coming from? Where were these containers coming from? The storage of the containers. And of course, security scanning, that was a pretty big one for the company too, making sure that we're keeping up with all of the latest updates, et cetera, et cetera.
Yeah, and also the part of the confidential containers, when you are deploying these on enterprise, some companies are very sensitive and they start using confidential containers with confidential computing, which is to be sure that the things that the container is executing, it's like a security part, right? So you are be sure that is the application which is actually running this, and it's not a hacker, it's not nothing. I mean, confidential computing is a broad conversation, but it is actually available because it's actually containers. So if you're using, and there's a part of the project that is related with security. If some of you is interested on security topics, there's a working group, so you can be part of that, you can contribute. But that's another part, because the main goal of this project is to focus to enterprise deployments. So everything related with scalability, security, with more deployments, is what the project provides you the tools for that.
Cool.
And what I will do now is actually show you how the repo is. So we can navigate to the repo. So the repo actually have multiple projects or parts. If I don't share it, it will be complicated. Let me entire screen. Here we go. Yeah, nice. So the project has multiple parts. One is GenAI example. One is GenAI examples, which is where you have all the blueprints. Nice. If you navigate here, you will see all those blueprints: agent Q&A, audio, avatars, tons of them, and they are blueprints. What I mean with blueprint is you have the entire pipeline, the same thing as we showed, but this actually adds the UI and adds a very simple UI, not a fancy UI because it's like oriented for POCs, and also provides an Nginx in the middle. You can use the Nginx or you can use your own load balancer you want. But that's the mindset of, hey, if you are deploying this on an enterprise, you need to use a load balancer. You need to expose everything to the world. And that's also included on the deployment. It comes with two main options. One is Docker Compose, if you are using Compose files, or Kubernetes, if you like to use a more professional, a more enterprisey development. And the Docker Compose, for instance, is divided by hardware. And this is what we say when we talk about vendor locking. Even if the project has 1 year, more than 1 year, I think it was.
A little more than a year, yeah.
Yeah. It was donated by Intel to Linux Foundation 1 year ago, but it doesn't mean that it only works for Intel. There are options that those containers are specifically optimized to run on specific hardware. Same have the NVIDIA NIMs, which are the particular components optimized just for GPUs. Those components like the LLM, for instance, how you do the similarity search. AMD and Intel will provide optimized components that can accelerate how the search is done or how the LLM is working, like using VLLM or more optimized. And there's another option that you can use the model to run. Probably you don't want to use it locally. You would like to use Bedrock. You would like to use OpenAI. We can talk about when you should use all of this, but it's a different talk. But you have the option to also to do it here. So in that case, I will navigate to the Intel. It's divided also by CPUs. The example could run on CPUs on Gaudis, which are the ASICs, and not the GPUs, the AI accelerators. Intel has one very important, it's called Gaudi. I'm going to the CPUs. In CPUs, you can run the example in AI PCs, which is basically similar to what I'm running here in my computer, or the Xeons, which is the big servers that you can use. In here, you have the Docker Compose file, which mainly you specify. Let's go to this one. In the Compose, you specify which vector database you are using, which retriever are you using, which, I don't know, data preparation, the VLM service, for instance, and all the things related with which model are you using. Models or parameters of the models, they are all environment variables for each particular container. So when you are creating your Compose, you will say, I would like to use this model. You set that model as an environment, and with those particular parameters, and the model, you go. And the model will pick the container. We'll download this model from Hugging Face, usually, and we'll install it within the container. And this is how you actually change everything. So, or you can build your own component. Like I imagine those components, OPEA provides the framework, on the communication framework, on how the components talk to each other. So the component has to be a specific format or API, because how you expose the API is very specific from the OPEA, so you need to create a container using these basics. But once it is there, and this is why we have too many partners, because each partner, each vector database is actually contributing their container to the project. Right? And you deploy it, and Docker Compose, if you are running with Compose, you need to set some environment variables, which is your Hugging Face key. If you're using proxy, you specify which model you'll be using. Docker Compose app, and you have this example, the end-to-end example, which are all those containers, chat Q&A, UI, the retriever, the embedding, and all of those containers you have there in your environment. Just to review something on the vector, on the variables, these are all the variables that you can set. For instance, in that case, the example uses 8 billion parameters llama. You can use DeepSeek here. You can use any one that is available on Hugging Face. You can change the embedding model, same thing. They are all downloaded from Hugging Face, so you put the route when you use on Hugging Face. And it has another part that also talks about Grafana dashboards. If you enable that, you will have dashboards in your deployment. Or you can go and you can download the Helm chart. The Kubernetes provides the Helm chart, which is the version to run on Kubernetes. So this is very for enterprises or for you to play. If you like to download it, you can play. If you like to go one step ahead, you can contribute your own component. Let's suppose you have a new technique, cleaning technique for data preparation. You can change the data preparation microservice to add that specific technique that you're using. Of course, the data preparation microservice, it supports tables, images, text, PDFs, URLs, but probably would like to add something specific. What happened 1 month ago or 2 months ago, a company that was working on finance, they said, this is not useful for me because how we clean up the data on finance is totally different. We need to do entity embedding, entity recognition, and so on. So they contributed their part that is for finance, it's specific for finance. And this is like the beauty of the open source, right? So the project is totally open, and anyone can submit their part. If you're working with agents too, there is an agents section, an agent example, that you can contribute your own agent. There is a specific, we're not talking about agents, but just to give you an idea, the same concept, except dividing everything on microservices. The same concept applies for the agents example. And you can very easily plug your own agent that you are deploying or using to this application. For instance, the example provides RAG agents, which is what we've done, but as an agent. There is a SQL agent that works with SQL, and there is a React, which is a specific strategy for supervisors. I mean, instead of just getting what it has, is reacts, which is reasoning, and acts. So reasons the answer of the agent, and based on that, probably talks to another tool or another agent, or gives the answer. So that kind of intelligence is available as a supervisor. Or if you would like to add a new one, there is a form, there are some instructions on how you could just add your own agent. If you're working with agents, you might be wondering, what about MCP? So MCP will be available in the next version, which is in 1 month or 2 months. Because every release, again, as it's enterprise and it's stable, the project has to be verified that, hey, we are enabling you to use MCP. So in the next version, that will be available. So if you like to add a new agent, you can add the agent using the MCP protocol. What else? There's a part with courses, too. If you like to learn a bit more, there is a course material, which are basically Jupyter notebooks, which explains those blueprints and how to run them. Deploy, this is something that I started 3 weeks ago. So the examples we have are only on agents now. So how to deploy the agent, how to customize the RAG agent, and how to add a new agent. So this is a Jupyter notebook where it gives you instructions. This is educational. It explains how it works and everything. So you can go here and you can also learn. And that's it for the repo, I think, yeah. And the evals part. Right. So it's all a toolkit, multiple toolkits that you have to use for your, here we go. Cool. Works?
Cool. So yeah,
Yes, cool.
if you want to get started, if you want to start playing with yourself, this project, go ahead and use this QR code. I'll just take you to the README section. It's like there's like a getting started page there that you can experiment with. That is where I got started when I wanted to start playing with this. There's a little bit of if you build it, they will come mentality here. There's a lot here already, but what we're looking for is people to contribute. And what I mean by contribute, not only just contributing code, but there is a lot more to build, but also just give us your feedback. Let us know what's working for you, what isn't working for you. If something isn't working the way you expect it to, let us know, because I'm sure there are use case scenarios out there that aren't being considered or that we've just missed, right? There's a lot of people involved in this, so we feel like we've touched a lot, but there's always ways to improve.
Yeah. And we are not specialists on everything, and the people that is contributing, same with the finance or with security. This example, for instance, this person contributed the guardrails, so the prediction guard, which is a company that works on that, but they say, I would like to contribute the guardrails for both to check the quality of the questions and the quality of the answers. So they contributed that to the project. And this is the kind of examples, because we don't know everything, and no one knows everything. So rely on the community to say user expertise and provide something to improve the project, right? So.
So just about everything can be found just directly from opea.dev. And there are several working groups that are active right now. I think we have a documentation one, security one. These are pretty active. Bring your use cases, of course. Obviously contribute code if you can, but we also need documentation. We do need that feedback. Blueprints, if you feel that there's something specific that would be helpful for others in the community, that would be great. Testing. Lots of that still needs to be done. And of course, talking about it, which Easy and I have been doing for a while.
Yeah.
We've done it in a few places. We have some stickers here. Bring your stickers, put them on your laptops, share the project with others so that we can get this community growing.
If you are here tomorrow, how many of you are here tomorrow? Okay, we have a mini summit, the part of the LFAA and data. We will be showing some integrations that OPEA with other projects, but there will be some sessions and something about it too. So, cool. We have 5 minutes or 10 minutes for questions. So thank you so much for your time. We appreciate it. And we will open up to questions.
Do you say that MLflow and Triton are play in the same space as OPEA?
I would say kinda. Actually, that there is an integration to use Kubeflow to orchestrate, because what the project will give you is the deployment. Right? So how you handle the scalability, how you handle the observability, how you handle all this part is part of the project, the other project that will be plugged into the OPEA part.
Yeah, I think I was referring to MLflow. I know Kubeflow exists, but
Yeah.
I feel that this as a platform competes with Triton from NVIDIA. NVIDIA has their own platform.
Not exactly.
No, it doesn't. Okay,
No.
that's what I was
Because
trying to find out.
that's a great question. What NVIDIA has is two things. One is the NIMs.
Yeah.
The NIMs is one particular component optimized for GPUs, the same thing as those components, but for GPUs. And they give you like blueprints or ideas on how you should build your containers. But it's something that they are proposing that, just because how they think that things has to be done. This is not Intel proposing, is not any of the companies proposing, is we got together with more than 50 companies and we are saying, or with the community, we are saying this is the best way to do the things. So we avoid the vendor lock-in and everything. So in terms of concept, yes, NVIDIA provides a similar blueprint, but it's a totally different mindset. Right? This is community, open source. There's no one company behind that. It's multiple companies. And NVIDIA just works for GPUs. Right?
Right.
So,
do you think that, just like the way we heard in the keynote today with Valkey and Redis,
yep.
will we run into a scenario like that with OPEA down the line?
What do you mean, to integrate with Valkey or
No,
to have the
not
same
to-
thing that happened with Redis?
I'm talking about distributed decision making. Because the code base is donated by Intel, right? Most of it is, so the decisions most likely will be driven by Intel.
Yeah, but the project is part of the Linux Foundation.
So I can kind of answer this one.
Yep.
So we do have a technical steering committee, and we do have some rules about how many members from one company can be a part of that committee. So in particular, I think there's 2 from Intel on that board
Yeah.
right now, and the rest of the positions are filled by different companies. So we do have part of the charter and part of the rules, the governing rules, to make sure that that doesn't happen, that one company doesn't own it. Now, it does so happen, Intel does have some full-time employees that are all about this, so they do a lot of work, but that doesn't mean that anyone else can't contribute as well.
Yeah. Yeah, the project cannot change the license because they want.
Right.
And that's another thing to being part of a Linux Foundation project. That gives you all this umbrella that you are sure that there's not one company doing whatever they want.
Should this be a specification first? That was a question.
Yeah.
And I think that's the point of the project,
That's the
is
point
they're
of the
trying to
project.
develop that.
Yeah.